All right, we're looking at answers to AP test review number 1. First one, we have a container that has a shape of an open right circular cone as shown in the figure above. The height of the container is 10 centimeters and the diameter of the opening is 10 centimeters. Water in the container is evaporating so that its depth, h, is changing at a constant rate of -3/10 centimeters per hour. Volume of a cone is V equals 1/3 pi r squared h. First thing we want to find is the volume of the water when in the container when h is 5. So that's just plugging in to this formula right here. So I just need to figure out what my radius is and what my height is. So they gave me a height of 5. I need to figure out what my radius is. Well, if you notice this full figure, the diameter and the height have a 1-to-1 ratio. And we remember that the radius is half the diameter, so that means the radius is going to be half the height. So if my height is 5, then that means my radius is 2.5. So I plug in 2.5 as my radius, I plug in 5 as my height. I didn't fill it out, but I believe the answer is 32.724. And my units on that would be centimeters cubed, since I'm finding volume. Part B, find the rate of change of the volume of water in the container with respect to time when h equals 5 centimeters. So rate of change of volume is going to be dV over dt, which means I need to take the derivative of this. But as we know, we don't want two variables over here on the right, so we need to get rid of one. If I come back up here, it says h is changing at -3/10 centimeters per hour, so this means this is dH dt. So I'm going to use dH dt, which means I want h to say and I want r to go. So that means I need to figure out what r is in relationship to h. So we already said that 2 times the radius is going to be the height. So if I solve for r, that means r is going to be h over 2. So I plug h over 2 in here. I square it, gives me h squared over 4. I move the 4 to the front with a 3, which gives me a 12. I do h squared times h, which gives me h cubed. Now I'm ready to take the derivative because I have a variable on each side. dV dt on the left. Bring the 3 down. This reduces to 1/4. Now we have h squared. Don't forget the dH dt. Then it's just a matter of plugging in. They said my height was 5, so this is going to be 25. dH dt is this. Work it out. I get -15 pi over 8 centimeters cubed per hour. Then part C says, show that the rate of change of volume of the water in the container due to evaporation is directly proportional to the exposed surface area of the water. Okay, what is the constant of proportionality? So surface area is going to be the top of this circle up here. And so that's just the area of a circle, which is pi r squared. So that means I need to manipulate this thing to end up with pi r squared, which means I need to go back to this. And instead of getting rid of r, I now want to get rid of h. Okay, so we set up here h is equal to 2r. So I'm going to plug 2r in for h. I'm going to move the 2 to the front with the, so that's going to be 2/3, and r times r squared is going to be r cubed. Now we're ready to take the derivative. So this is dV dt. I bring the 3 down, it's going to cancel with this 3, give me 2 pi r squared times dr dt. Okay, so there's the pi r squared that I want. So now I need just the coefficient of it. So the 2 is there, but I need to figure out what dr dt is. They gave me dH dt right here, so I need to figure out what dr dt is. Well, if I go back to this formula, 2r equals h, and I take the derivative of both sides, I get 2 dr dt on the left, I get dH dt on the right. I plug -3/10 in for dH dt. I divide by 2. That gives me dr dt is -3/20. So I plug -3/20 in here. I multiply by 2. That gives me -3/10. So here's my pi r squared. So this is the coefficient. The coefficient is going to be my constant of proportionality. So -3/10 is what we're looking for. Number 2, x-coordinate of the point of inflection. We get points of inflection from the second derivative. So I'm going to take the second derivative, nothing fancy there. I set it equal to 0. I solve, I get -5. And I get one choice that's -5. Now, if one of these had said no point of inflection, then I would want to do a sign line and verify that it changes signs. But in this case, I don't have that, so there's no need to go ahead and do the sign line. I'm guaranteed my answer to be -5. Number 3, just take the derivative of this. So derivative of x squared is going to be 2x on xy. Make sure we do the product rule. First derivative of the second plus the second derivative of the first. So the derivative of x would just be 1. That's why there's nothing there. And derivative of 10 is 0. Okay, that's a common mistake when you guys are working this, is instead of making the derivative of 10 be 0, you'll put 10 here. So don't do that. Now I want to plug in x equals 2. So I plug in x equals 2, and then I need to figure out what y is. As I've said many times, anytime I need something, I go back to the original. So I'm going to plug 2 in here, which is what I did right here. And then I'm going to solve for y. So I solve for y, and I get y equals 3. So that's why I have 3 here. So this is 4. This is 3, which is 7. I move it to the other side, gives me -7. I divide by 2. -7/2 is my answer. 4, particle moves along the x-axis so that its position at time t is given by x of t equals t squared minus 6t plus 5. For what values of t does the velocity of the particle equal 0? So that's just taking the derivative to get to the velocity function, setting velocity equal to 0, and solve. So there's my derivative. There's set it equal to 0. I solve. I get t equals 3. Bang. There's my answer. Number 5, the graph of a twice differentiable function f is shown in the figure below. Which of the following is true? So I'm looking at f. Make sure we understand we're looking at f. So f of 1 is the easiest one to find out. That's 0. F prime. Okay, I want to look at f and 2 things. I want to know, is it increasing or decreasing? Is it concave up or concave down? So at 1, f is increasing, so that means the derivative is positive. At 1, we are concave down, so that means the second derivative is negative. So that's why we like D. All right, consider the curve, find dy dx. So that's nothing but just taking the derivative. So we're going to do product rule here. We're going to do product rule there. Derivative of 6, don't forget that is 0. So first, derivative of the second, plus the second derivative of the first. Again, derivative of x is 1. That's why it's not there. Minus, then make sure we do parentheses because we got to get that negative distributed. So now we're doing product rule here. So first derivative of the second plus the second derivative of the first. Distribute the negative, which is what I did. Keep the y primes on the left and factor it out. Move the other 2 to the other side. So I move that over. That's going to become positive. I move that over. It's going to become negative. And then I divide. So there's my derivative. Part B says find all points on the curve whose x-coordinate is 1. And then we want to write the equation for the tangent line at each of these points. So find all points where x is 1. That just means I need to plug x into my original and find y, and then I've got my points. So that's what I did. Where's B? B's over here. I plugged in. I had to factor. I got 2 values. So I have 1, 3, and I have 1, -2. I want to plug those into the derivative to get my slope. So when I plug 1, 3 in, I get 0. When I plug 1, -2 in, I get a +2. So y minus 3 equals 0 times x minus 1 for this tangent line. And then y plus 2 equals 2 times x minus 1 for the tangent line that goes with 1, -2. Find the x-coordinate of each point on the curve where the tangent line is vertical. So if the tangent line is vertical, then that means the slope of that tangent line is undefined, which means I need to set the bottom of my derivative equal to 0, which is what I did here. I factor the x out and set them both equal to 0. So I plug x in to 0. And right here, I can't solve this, so I went ahead and solved for y. And once I solved for y, then I plugged y back into the original. So I plugged y back into the original and I cleaned it up. So this is x to the 5th over 4. This is x to the 5th over 2. I went ahead and multiplied everything by 4 here, which gives me this. Put these 2 together, gives me a negative x to the 5th. And then I have 24. Take the 5th root or move the negative, take the fifth root, we get the fifth root of negative 24 as the x value where we have tangent line is vertical. Now we had x equals 0, but the problem with that is when I plug 0 in here and I plug 0 in there, I get 0 equals 6, which is no good. Okay, so that's why x equals 0 did not work for me. I should really mark that out on my answer sheet. But this one's guaranteed to work because I plugged this back into the original, so I'm guaranteed to get that one to work. 7, equation of a tangent line. Again, as soon as you hear a tangent line, you should be thinking slope and point. There's my point to get my slope. And when you hear slope, you should be thinking derivative. So the derivative of this thing is 1 minus sine. I plug in 0 and 1. So that gives me 1 minus sine of 0. Sine of 0 is 0. So that means my slope is 1. So y minus my y value equals my slope times x minus my x value. I add the 1 over, and we get y equals x plus 1. Number 8, find the instantaneous rate of change at x equals 2 for the given function. So that just wants me to take the derivative and plug in. So instantaneous rate of change is just plugging into the derivative. So this is going to require quotient rule. So bottom derivative of the top minus the top derivative of the bottom over the bottom squared. I'm going to plug in 2. I plug 2 in everywhere. I end up with 2 as my slope, which is also my instantaneous rate of change. Number 9, we just want f prime of pi over 6, so I need to take the derivative and plug in. Derivative of tangent is secant squared. Inside stays the same. Don't forget to take the derivative of the inside. If you mess up, that's probably where you mess up. Don't forget to take the derivative of the inside. I plug in pi over 6, so that gives me secant of pi over 3. Secant of pi over 3 is equal to 2. 2 squared is 4. 4 times 2 gives me 8. All right, the function f is continuous on the closed interval from 2 to 8 and has values that are given in the table above. Using subintervals 2 to 5, 5 to 7, and 7 to 8, what is the trapezoidal approximation of that interval? So trapezoid, we're going to have the 1/2 out front, and then we just need the distance between the x values times the y values added together. So 2 to 5 gives me 3, 10 plus 30 gives me 40. 5 to 7 is 2, 30 plus 40 is 70. 7 to 8 is 1, 40 plus 20 is 60. Clean all that up, we end up with 160 as my answer. Which of the following statements about f is true? So f of x equals the absolute value of x. We should remember that the graph of that thing looks like a V, and the vertex of that V is at 0. Okay, so is f continuous at x equals 0? Yes, it's a V. There are no breaks, no holes, no jumps, no asymptotes, so it is definitely continuous. Is it differentiable at x equals 0? The answer to that is no, because we have a sharp turn at x equals 0. Therefore, it is not differentiable. F has an absolute minimum at x equals 0. Again, we're talking about a V. The vertex is the lowest point. Therefore, it is a minimum. So we like 1 and we like 3. So that's why we like the answer D. Number 12, differentiable function such that for all real numbers x, g of x is less than 0. So that means g is always going to be negative. And f prime of x equals this. Which of the following is true? So we're talking about maxes and mins in here. So that means I want to set the derivative equal to 0 to find my critical points, and then do a sine line to figure out if those critical points are maxes or mins. So here's my derivative. I set each piece. I don't really need to set g of x equal to 0 because it says g of x is always negative, which therefore means it can't be 0. So x squared minus 4, I solve that, I get 2 and negative 2. I plug that on my sine line. So I'm going to plug in 0. Make sure you plug it in right here. So if I plug in 0, I get a negative on this piece, and this tells me that g of x is always negative. So a negative times a negative gives me a positive. Plug in 3. 3 squared is 9, so that makes this positive. This is always negative. Positive times a negative gives me a negative. Over here, negative 3. Negative 3 squared is 9, so this is positive. This is negative, ends up giving me a negative. So that means I have a minimum at -2 and a maximum at 2. So that's what we have here. Remember, another word for relative is local. So that is your answers for AP Test Review number 1.